I am introducing a video of driving a Mitsubishi linear motor at a maximum speed of 3 meters per second using the Motorcoder, an absolute position linear sensor with Hall sensors. I can drive a linear motor using a scale-free Motorcoder and a Mitsubishi servo drive. I can use a Mitsubishi servo drive or a Panasonic servo drive. For comparison, I installed the Motorcoder for control and an optical linear encoder for measurement. The optical linear encoder outputs an incremental signal, which is input to the first Mitsubishi servo drive, and the position data sensed by the Motorcoder is input to the second Mitsubishi servo drive through serial communication. Two servo drives are connected to a Mitsubishi PLC. To measure speed, I control the linear motor a second servo drive through a PLC using the Motorcoder. I simultaneously receive and save position data from two sensors and two servo drives using PLC. I drive a linear motor with a travel distance of 1 meter, at speeds of 1, 2, and 3 meters per second. First, I drive a linear motor at a maximum speed of 1 meter per second. For a detailed comparison, I save the position data received from the two sensors and viewed it on a graph. The x-axis is time, and one division interval is 150 milliseconds. The y-axis is position and speed. The green line is the position of the Motorcoder, and the pink line is the position of the optical linear encoder. The blue line is the Motorcoder speed, and the red line is the optical linear encoder speed. Since the Motorcoder resolution was about 0.7 micrometers and the optical encoder resolution was 1 micrometer, the Motorcoder moved by about 1.4 million counts, and the optical linear encoder moved by 1 million counts. Looking at the red and blue lines, you can see that the linear motor operated at a speed of 1 meter per second. Secondly, I drive a linear motor with a speed of 2 meters per second. I displayed position and speed in the graph. Looking at the blue and red lines, you can see that the linear motor was running at 2 meters per second. When the linear motor was driven at 1 meter per second, it started running at about 150 milliseconds and stopped at about 1.2 seconds, but when driven at 2 meters per second, it stopped at about 750 milliseconds. Finally, I drive a linear motor with a speed of 3 meters per second. If you look at the speed graph, you can see that the linear motor was running well at 3 meters per second. A linear motor started running at about 150 milliseconds and stopped at about 600 milliseconds. Because it is based on serial communication, the Motorcoder has no maximum speed limit and is highly resistant to noise, making it suitable for long-distance transport. I plan to upload data from various linear sensors. If you turn on notifications, it will be more convenient when you watch the next video. Thank you for watching. SensorLab.